Alright, here we are with our pre-calculus trig test 1 review. You guys asked, and so you shall receive the review. Okay, I just want to kind of go over the topics one more time. If you would like to at any time pause the video after I present a problem, and that way you could then go ahead and try to solve it on your own, hit play, and see how it's done. Let's start off with a couple converting problems. That's the first major topic on our test. So if I was to take 118 degrees and convert it to radians, so go ahead and pause now if you want. And anyway, to convert this to radians, I'm going to multiply by my conversion factor. And because I want the degrees to cancel, I'm going to put the 180 degrees on the bottom. I'm going to put the pi radians on top. That way my degrees cancel. Now when I use my calculator, I am going to hold the pi. And I'm just going to type in 118 divided by 180. Make sure I get a reduced fraction. And it's a weird fraction, but nevertheless, it is 59 over 90 pi. Don't forget to put the pi back in there. So there it is. Pretty nice and simple. Let's do a conversion one now of radians. So if I have 9 pi over 5 radians, I'm going to convert that to degrees. So I'm going to go ahead and multiply this. This time I want the 180 on top because I want to end in degrees. I'm going to put the pi radians on the bottom. That way the radian measurements or the radian units cancel. Very fortunate for me, the pi's will cancel in this problem. And I just get simply 9/5 times 180. Which is 324 degrees. So pretty easy problems right there for converting. So hopefully those make sense to you guys. All right, I got a couple more problems ahead here. Let's look at a problem with a 30, 60, 90 triangle. So here's a problem here. We got a 30, 60, 90 triangle. And I'm going to tell you that the hypotenuse is 18. So if you want to go ahead and hit pause and try it out, go right ahead. I'm going to continue on here. The 18 is the hypotenuse. If you look at your trig folder, you'll realize that the hypotenuse is supposed to be 2x. Divide by 2, divide by 2, that means that 9 is my x value. Well, across from the 30 is the x value, so that would be 9. And across the 60 is typically x times radical 3, so for me that would be 9 times radical 3. And done. Very, very, very easy. Now, I want to remind you guys, I've done this in the past, but I want to remind you guys, once you have this 30, 60, how easy it is. So if I asked any of you, what is sine of 30 degrees, you should easily be able to look right here and say, that'd be opposite over hypotenuse. That would be 9 over 18. Hey, 1/2. That should always be the case for sine of 30 degrees. Cosine of 30 degrees. Okay, well that is adjacent to 9 radical 3 over hypotenuse of 18, which reduces to radical 3 over 2, which is always the case. Don't believe me? Look on your unit circle 30 degrees and you'll see that sine 1/2 is the y value. Cosine radical 3 over 2 is the x value. And don't forget about tangent. Tangent is opposite 9 over adjacent 9 radical 3. 9's cancel and I get 1 over radical 3, which is a great answer, but I don't really like the radical down the bottom there. So multiply the top by radical 3 and the bottom and you just get 3. So there is my tangent of 30 degrees right there. Very, very, very simple stuff. All right, let's move on and take a look at another problem here. Let's give you a triangle. And I would maybe present this problem like so. And I would say right here is alpha, right? 9-degree triangle. And I'd say there we go. Maybe find the 6 trig functions of alpha. Find all 6 trig functions of alpha. So the first thing you got to do is say, well, wait a minute. Hey, this is great. I know sine of alpha. Sine of alpha is opposite 5 over hypotenuse 13. This is great, but wait a minute, cosine, I need the adjacent side. So real quick, we'll do 5 squared plus a squared equals 13 squared. That is 25 plus a squared equals 169. Subtract the 25 over and you get 144. Square root, and you get a is 12, which is very, very nice, especially since it's a nice whole number. So now cosine of alpha is 12 over 13, adjacent over hypotenuse. Tangent of alpha is opposite over adjacent, 5 over 12. And now we can find their cousins. Cosecant of alpha is going to be the 13 over 5. And secant of alpha is 13 over 12. And lastly, not leastly, cotangent of alpha is 12 over 5. So very, very simple when you are given a triangle. So that's basically finding the 6 trig functions of any triangle. So very, very simple stuff there. All right, another question you could ask is to solve the triangle. Remember, solving a triangle is trying to find all the angles and all the sides. So let's give you a quick problem like this. I'm going to use some different colors here. I like to mix it up. So we got a right triangle, and this is I don't know, 17 degrees. Okay, and let's say the hypotenuse here is 19. Solve the triangle. So first thing I'm going to do is find this missing side here, and that missing side would simply be 180 minus the 90 degrees minus the 17 degrees, and that would be a 73 degree angle. That's not really drawn to proportion here, but you get the idea. That's 73 degrees. And now I want to find the missing sides. You could find either side you want first. Let's just say I want to find this side right here. I'll call it A first. So now I'm going to use the 17 degrees that I was given, and I'm going to use the 19. I'm going to use the two things that were given. A is adjacent, 19 is the hypotenuse. So that's cosine. Cosine is the guy that uses adjacent and hypotenuse. So cosine of 17 degrees is the A, the adjacent, divided by the hypotenuse of 19. And boy, is this simple to solve for. Just multiply both sides by 19. So I get that A is simply 19 times cosine of 17. Make sure your calculator is in degree mode, and I get 19 times cosine of 17. I get 18.17. So 18.17 is my value for A. Now to find that B value over here, I'll call this B. Again, I want to still use I want to use the 17 degrees that was given, and I want to use the 19 that was given. So again, B is the opposite, 19 is the hypotenuse, that's sine. So sine of 17, sorry about that. I wrote that wrong. So sine of 17 degrees is going to be the opposite B over the hypotenuse 19. So once again, multiply both sides by 19, and I get my answer real nice and quick for B. So it'd be 19 times sine of 17 degrees is 5.56. So very simple, quick problem right there. Now I would like to do one more of this just to show you a different thing that could happen here. If I give you a right triangle, and I told you that the hypotenuse is 21 and that this leg right here was 6, and I said solve the triangle. Well, the first thing I got to use is the Pythagorean theorem, so I know that 21 squared equals 6 squared plus, we'll call that A squared. So that's going to be 21 squared is 441 equals 36 plus A squared. Subtract that 36 over, and I get 405. And now I got a square root, and now I got to figure out, can 405 be reduced? And it's not divisible by 25. Is it divisible by 36? No. Is it divisible? I'm trying to reduce 405 because I just want to teach you the importance of at least trying to reduce here. I'm just dividing 405 by numbers, and I'm trying to find something that works. Oh, wait a minute. I'm on to something. 405 is, I believe, divisible by, let's see here. I think it's divisible by 81. Yeah. 405 is, believe it or not, I can't believe I stumbled across it, 81 times 5. So 405 is going to be 9 radical 5. That is my missing value here. Wow. So it does pay off to keep trying options. The 81 comes out. Excuse me, a little sneeze in the video there. Never hurt anybody, right? The 91 comes out as a 9. So we got 9 square root of 5. So that's a 9 square root of 5. So anyway, now I got to find the angles. So let's try to find this angle first. I'll call it A. Big capital A for fun. Okay, so I know that the 6 is the opposite, 21 is the hypotenuse. So that's sine of big A equals 6 the opposite over the hypotenuse of 21. So now to find A, I'm going to pull the old switcheroo using inverse trig functions. So the inverse sine of 6 over 21 is how I'm going to find A. So that's going to be on my calculator second sine. So they pull up the sine inverse, 6 out of 21. And that gives me 16.60 degrees. 16.60 degrees for angle A. And that means to find the other angle, I'm going to take 180 minus 90 minus 16.60, and I get 73.4 degrees for, let's call this angle B right here. So 73.40 degrees would be the other angle B. So notice how I used the two things that were given, 21 and 6, to find that angle for me. So anyway, hopefully a problem like that makes sense to you, because you'll see one of those on your test as well. All right, now let's get into some of the stuff at the end of the exam here that we want to talk about. For example, a point. So maybe I give you a point here, like -8, -2, and I want you to find all the trig functions at this point. Well, let me first explain what's going on here. First off, -8, -2 is somewhere over here. So I want you to envision this triangle here that is created with the x-axis. So envision this triangle here where this would be the radius. That would be the radius, the distance to the center. Then we got the height of the triangle would be y, and the horizontal distance of that triangle would be x. So we have this triangle here, and we have our angle right here. This is the x, y, and r. So this is the connection between x, y, and r. And we know x is -8. We know y is -2. And now all we got to do is figure out r. So we have -8 squared plus -2 squared equals r squared. So please make sure you know that -8 squared is 64. It's not going to be negative. A negative squared is always positive. -2 squared is 4, and this is r squared. So we get 68 equals r squared, square root, square root. I do need to see, can 68 be reduced? It does seem like it. Yes, it can. 68 is 4 times 17. So the 4 comes out as a 2. So 2 radical 17 is my radius. So I got r, I got x, and I got y. Everything I need is involved in these two circles. So let's find sine. So sine of this angle, right, that goes all the way to that value there, I'll just call it theta, is going to be y, -2, over r, 2 radical 17. So notice a couple things are going to happen here. First off, the 2's are going to cancel, and I get -1 over radical 17. But I realize I don't like that radical 17 down there, so I multiply top and bottom, giving me negative radical 17 over 17 as my final answer for sine. Cosine of theta. Cosine is going to be the x, -8, over the radius of 2 radical 17. Once again, a couple things are going to happen here. First off, the 2 and the 8 are going to reduce to -4 over radical 17. Then once again, I don't like that radical 17 down there, so I multiply the top and I multiply the bottom, resulting in -4 radical 17 over 17. One more to go here, and this is the easy one. Tangent is y over x, so -2 over -8. Two negatives makes a positive, and those 2 and 8s would reduce to a positive 1/4. And now I'm going to try to find their cousins real quick here. So cosecant of theta is going to be, remember, r over y. So that'd be 2 radical 17 over -2. 2's cancel, and I just get negative radical 17. Don't forget that negative was left behind there on the bottom. Secant is going to be r, 2 radical 17, over x, which is -8. So the 2 and the 8 are going to reduce to negative radical 17 over 4. Hopefully you could see this. Probably not, so let me put that over here. Negative radical 17 over 4 there for secant. And lastly is cotangent. And cotangent is going to be x over y, so -8 over -2, which reduces to positive 4 over 1. So very, very simple there. Hopefully that all makes a lot of sense to you guys. It's all about finding r. Once you can find r, your options are pretty much limitless. Just make sure that you are careful in reducing everything. So pretty easy there. All right, so let's move on and let's take a look at another problem here. I'm going to give you that cotangent of theta equals radical 7 over 5. And I'm also going to tell you that theta falls between pi and 3 pi over 2. And I want you to use this two pieces of information. A, I'm going to give you cotangent. B, I'm going to tell you that theta lies between pi and 3 pi over 2. And I want you to find all the other trig functions. Okay, so let's think this through. First off, I have 1 down, 5 more to go. Think of it as a numbers game. You got to find 5 things now. Well, first off, I know that tangent and cotangent are just reciprocals of each other. So if I take cotangent and flip it over, 5 over radical 7. And then I say, well, wait a minute, I don't like that answer. Multiply top and bottom by radical 7. I get 5 radical 7 over 7. There's tangent. So now I got 2 down, 4 to go. Now it is important for me to realize what quadrant I'm in, and that's based on here. Remember, pi is right here at 180 degrees. 3 pi over 2 is down here at 270 degrees, and use your unit circle if you need to. And I'm down here in between. Theta is somewhere down here in between in quadrant 3. In quadrant 3, x's are negative, y's are negative, and 2 negatives would make tangent and cotangent both positive. So that does work out. Okay, next up, how do I find the remaining guys? Well, I'm going to use the XYR method. Remember, tangent is y over x, and cotangent is x over y. So from the very, very beginning, since cotangent was radical 7 over 5, which is x over y, please make sure you have that down in your trig folder. I know that x is radical 7 and y is 5. And I could use those two things to help me find r. So remember, x squared, which is radical 7 squared, plus y squared, which is 5 squared, equals r squared. So that's going to be radical 7 squared is just plain old 7, plus 25, which is 5 squared. So 7 and 25, 7 plus 25 is 32. So I get 32 equals r squared, square root. Okay, now let's see if this can be reduced. 32 is divisible. I know it's divisible by 4, guys, but it's also divisible by 16, which is bigger. So 32 is 16 times 2. 16 comes out as a 4, so it'd be 4 radical 2 is r. Now that's awesome news. So I got x, radical 7. I got y, 5, and I got r. If you would rather do the triangle method, I know some of you would rather do the triangle method, and I'll briefly show that real quick. Remember, with the triangle method, hopefully you have in your notes that cotangent is adjacent over opposite. So what you would do in that case is you would draw a triangle, and you would mark one of the angles theta, and the adjacent would be the radical 7. The opposite would be the 5, and then when you use Pythagorean's theorem, you would get 4 radical 2 for the hypotenuse, which is basically your radius. So it all does work out the same way, however you want to look at it. So now I'm ready to go. Let's see here. Sine. Sine is y, 5, over the radius, 4 radical 2. Great answer, but I'm going to multiply the top and bottom by radical 2, which gives me 5 radical 2. Now the bottom, when I multiply by radical 2, I get 2 times 4, which is 8. So hopefully that makes sense to you guys. But wait a minute, I'm in quadrant 3, and y's are negative, so that would need to be negative. So the y there is negative, and so is the x, because in quadrant 3, x and y are both negative. So make sure you got a negative there. Okay, and then let's see here. Cosine of theta is going to be, again, based on your trig folder, is x radical 7 over r, which is 4 radical 2. And once again, I'm okay with the radical 7 on top. I don't like the radical 2 down there, so I'm going to multiply top and bottom by radical 2. And I get radical 14 on top, and then I get 8 on the bottom, because the radical 2 and radical 2 makes 2. 4 times 2 is the 8. So radical 14 over 8. Don't forget to make sure that's negative, because we are in quadrant 3. Now for their cousins, let's see here. Cosecant. It's best if you use the definition of cosecant, which is r, 4 radical 2, over y, negative 5. So there's my answer right there for cosecant, already done and good to go. Don't forget to make sure it's negative, because you're in quadrant 3. And one more to go, secant. Secant is using the definition. Secant is x, negative radical 7. Oh, I'm sorry. I said that wrong. My fault. Secant is r on top. Secant is r on top. So r is 4 radical 2. And on the bottom is negative radical 7, which is my x value. Multiply top and bottom by radical 7. Let's see if we can figure this out. On top, I get 4 radical 14. On the bottom, I get a 7, because radical 7 times radical 7 is just 7. And then don't forget there is a negative there, again, because I'm in quadrant 3. So I got cotangent, tangent, sine, cosine, cosecant, and secant. All done. Check, 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 check. Very, 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 very easy. So hopefully you guys are able to do those types of problems. Please make sure you focus on whether you do the XYR method or the hypotenuse, opposite, adjacent method, the triangle method. Please make sure you find everything correctly. Be careful you realize what quadrant you're in, because that determines if x and y is negative or positive. R, the radius, the hypotenuse, is always positive, just so you guys know. All right, let's move on. I just want to end the video with a couple more of these practice problems where I ask you for random ones here. So for example, if I said, what is cosine of 26 pi over 3? If you want to try it on your own, go ahead and hit pause now. Now the issue is, where the heck is 26 pi over 3? I don't see it on my unit circle anywhere. So what you would do is you would type into your calculator 26 thirds. Please make sure you use parentheses. And be careful to hold the pi. Hold the pi. Now, it's too big, so I'm going to subtract 2. And I get 20 thirds. I don't see that either. I'm going to keep subtracting 2, 14 thirds. Keep subtracting 2, 8 thirds. I still don't see this on my unit circle. Keep going. Aha! I found out that 26 thirds is the same as 2 thirds pi. It's just different rotations around the circle, but it's no difference. So now I know where to look on my unit circle. So I'm going to go ahead and I'm going to look at 2 thirds pi. Hopefully you guys see where that is. And cosine wants the x value, and the x value 2 thirds pi is negative 1/2. Done. How easy was that? Let's check out another one here. Sine of 19 pi over 4. Again, if you want to try it on your own, go ahead and hit pause and try it out. Sine of 19 pi over 4. Well, first off, I got to find 19 pi over 4. It's not on my unit circle. So type it into your calculator with parentheses around it. And I got to think, okay, let me subtract 2. 11/4. Nope, don't see that either. Oh, 3/4. Wait a minute, I subtracted 2 twice, and I got it down to that is simply 3/4 pi. Wow, that's awesome, because I know where 3/4 pi is. Find 3/4 pi, and sine is the y value, which is radical 2 over 2. Done. There's your answer. Very, very simple. Very, very easy. Another one, secant. Secant of negative 11 thirds pi. Okay. Well, where do I look? I got to find negative 11 thirds. I don't see it. Okay, use your calculator. Negative 11 thirds pi. Hold off the pi. I'm just typing in negative 11 thirds in my calculator. And this time, because it's negative, I'm going to add 2. And I get negative 5 thirds. I don't see that either. Add another 2. And I get 1/3. I do see 1/3. Now, when we say 1/3, of course, we mean 1/3 pi, which is pi over 3, so I do see that. Don't get negative 5 thirds confused with positive 5 thirds. They're very different, so please make sure you keep going. So I got pi over 3 and secant. Okay, now I got to remember my rule. Secant is the reciprocal of x. So the x value at pi over 3 is 1/2. The reciprocal of 1/2 is 2. Done. Final answer. How easy. Let's do one more. Cotangent of negative 13 pi over 6. Okay, once again, I don't see negative 13 pi over 6 on my unit circle, so I'm going to go to my calculator. Negative 13/6. I'm not typing in the pi. I'm going to add 2 because it's negative. Add 2 again because I don't see that angle. And finally, I realize that negative 13 pi over 6 is the same thing as 11/6 pi. Again, I just kept adding 2 until I saw a fraction I recognized from the unit circle. So find 11/6 pi. It's in quadrant 4 down there in the bottom right. And now cotangent is x divided by y. So I got a little bit of dirty work. The x is radical 3 over 2 divided by the y, which is negative 1/2. Now, dividing by a fraction is the same as multiplying by its reciprocal, so negative 2 over 1. 2's cancel, and hey, just like that, I'm done. Negative radical 3 is my answer. Don't forget the negative didn't cancel. The negative was still there, so I got to leave that on my answer. How easy was that? Very, very simple. There's my answer. So, quick little review. Hopefully that was good for you guys. Hopefully you watched that, did a little pausing to try to do some problems on your own, and get ready for our test on Friday.